Lesson 4. Applications to modelling. You can use the techniques learnt in this chapter to find solutions to models of real-life situations. Let's do one example. The price of a car in pounds, x years after its purchase, is modelled by the function f of x is equal to 15,000 multiplied by 0.85 to the power of x minus 1,000 sine x, where x is greater than 0. Part A. Use the model to find the value of the car 10 years after its purchase to the nearest 100. Part B. Show that f of x has a root between x is equal to 19 and x is equal to 20. Part C. Find f prime of x, the derivative of f of x. And then part D. Using x0 is equal to 19.5, use the Newton-Raphson method to get a second approximation for when the value of the car is 0. Give your answer to 3DP. For part A, to find the value of the car 10 years after its purchase, all we're doing is finding f of 10. This is going to be equal to 15,000 multiplied by 0.85 to the power of 10 minus 1,000 sine of 10. Unless otherwise stated, you should always assume the angles in questions are measured in radians. This will give you about 3,497.13 and so on. And so therefore, the value is £3,500 to the nearest 100. Part B. F of 19 is equal to 15,000 multiplied by 0.85 to the 19 minus 1,000 sine of 19, which is equal to 534.11. And this is bigger than 0. If we look at f of 20, this is 15,000 multiplied by 0.85 to the 20 minus 1,000 sine of 20, which gives you negative 331.55, which is less than 0. And so therefore, there's a change in sign, and f of x is continuous on the interval 19 is less than x, which is less than 20, and so therefore there is at least one root. In the interval 19 is less than x, which is less than 20. For part C, the derivative of a to the x, where a is a constant, will be equal to a to the x multiplied by the natural log of a. And so f prime of x will be 15,000 multiplied by 0.85 to the x like before, but multiplied now by ln of 0.85. And then sine x differentiates to cos x, so this is just minus 1,000 cos x. For part D, we first need to find f of 19.5 and f prime of 19.5. f of 19.5 will be 15,000 multiplied by 0.85 to the 19.5 minus 1,000 sine of 19.5, which gives you about 0.0693, and so on. F prime of 19.5 will be 15,000 multiplied by 0.85 to the 19.5 multiplied by the natural log of 0.85 minus 1,000 cos of 19.5, which is negative 898.3009, so on. And we know, using the Newton-Raphson method, xn plus 1 is equal to xn minus f of xn over f prime of xn. So x1 will be 19.5 minus f of 19.5, which is 25.0693, and so on, over f prime of 19.5, which is negative 898.3009. And when you evaluate this, you get about 19.528 to 3dp. And that's about it.